Hi, this is lesson 6.5, solving absolute value equations. You should be on page 390. We talked about absolute values earlier in the year, but we're going to review it a little bit right now. The absolute value of a number A, written, and I'm going to circle, written in this form, that's what, when you see that symbolism, that means the absolute value of a number A. And this is asking you the distance between A and 0 on a number line. Now I'm going to underline distance because remember, distance is always a positive amount. And we got to remember that that's going to be important later on in the video. Distance means positive. Now an absolute value equation like absolute value of x equals 4 is an equation that contains an absolute value expression like you see here. Absolute value of x equals 4 would be called an absolute value equation. Now, it's important to understand that this equation is meaning that the distance between x and 0 is 4, and we're asking what numbers can I plug in here that would be 4 away from 0. And it's important to note there are two solutions to this problem. Absolute value equations will always have two solutions, because there's two numbers that are 4 away from 0. And you can see it in the picture here. The number 4 is 4 units away from 0, but so is the number -4. So when you look at this problem, the absolute value of x equals 7, there's going to be two solutions to the problem. Positive 7 is 7 away from 0, but so is -7. I want you to pause the video real quick and try those two. Alright, so what did you get? Well, you should have had that for this equation, x would be -3 or +3. I'll just put plus minus 3, there's two solutions. And for this equation, x would be plus or minus 15. It could be positive or -15. Solving absolute value equations. In example 1, notice that the expression inside the absolute value symbol equals 7 or the opposite of 7, which means -7 like we had. This suggests the following rule for solving an absolute value equation. If you're solving an absolute value equation, the equation where the absolute value is on the left equaling a number on the right where c is greater than 0 is equivalent to the statement ax plus b equals c, or ax plus b equals opposite c. Now you might be like, what in the heck is that trying to tell you? Here's what this is trying to say. It's trying to say that if you isolate, and maybe I should underline that, if you isolate the absolute value, this is equivalent to two equations. And you notice they have two equations listed here. One of the equations would have a positive amount, which you see here. Maybe I should circle that in green so it shows up. You see how one equation had a positive. The other equation has a negative result, which I'm circling here. Okay, so if you write an absolute value equation, you can rewrite it into two different equations that do not have absolute values in them. One would have a positive result, and the other would have a negative result. Let's look at that down here. They want us to solve x minus 3 and absolute values equals 8. Okay? Since the absolute value is isolated already, x minus 3 would have to equal 8, but x minus 3 would also equal -8. Now remember, absolute values always have two solutions. So whatever this works out to in here, it has to work out to +8 or -8. So look at what I did. I wrote two equations, x minus 3 equals 8, but I also wrote x minus 3 equals -8. Now I can quickly solve each. Let's do that. So for this equation, I'll add 3 to each side, and I get x equals 11. And for this equation, I'll add 3 to each side, and x equals -5. Let's check real quick and see if these two answers actually work. So let's go back here. 11 minus 3 is 8. Is the absolute value of 8, 8? And I hope you're shaking your head, yes it is. And it is. 8 is 8 away from 0. Let's try this. Let's put negative 5 in here. Negative 5 minus 3 is negative 8. Is the absolute value of negative 8 8 away from 0? And I hope you're saying yes, it is. So there's two solutions. 11 can be plugged in and make this statement equal 8, but so can negative 5. Absolute values always have two solutions to them, okay? Now, when you rewrite equations, you will have to rewrite absolute value equations for the following reason. To solve an absolute value equation, you may first need to rewrite the equation into that form. Now, if you're like, what are they trying to tell me here? They are trying to say, and this is super important, I'm going to highlight it here in green, you have to isolate the absolute value before you write your two equations out. Okay, in that last example, remember, I solved two separate equations. This is saying you've got to get the absolute value isolated before you write your two equations. In other words, you have to onion the absolute value. Let me show you that here. I'm going to erase this off so it's not interfering with what you see. In this problem, do you notice the absolute value is not by itself? Let me take my pen and let me circle here. Do you notice this absolute value is not on the left side of the equal sign by itself? I have this 3 here and I have the minus 5 here. I do not want the 3 and the minus 5 on the same side of the equal sign. The absolute value isn't isolated. So let me onion the absolute value. The absolute value is the center of the onion. The times 3 is the next layer. The outside layer is the minus 5. I got to peel away one layer at a time. So I want to get rid of that minus 5 first. So I will, and you can notice it down here, I'm adding 5. So these cancel, and I get 3 absolute value, 2x minus 7 equals, on the other side, 4 plus 5 is 9. Okay, now I don't want that times 3 outside the absolute value. I want the absolute value by itself. So I'll divide each side by 3. That will allow me to cancel the 3's on the left, and I get absolute value 2x minus 7 equals 3. Now, since the absolute value is by itself, I can write two equations, and I can get rid of the absolute value. Here's my first equation right here. It's 2x minus 7 equals positive 3. Here's my second equation. 2x minus 7 equals negative 3. To solve those, it's easy. Add 7 to each side, so let me do that. So if I add 7's here, you're going to get 2x equals 10, and if I add 7's here, I'm going to get 2x equals 4. And then the last step, divide each side by 2. So one answer would be x equals 5. If I divide by 2 here, I get x equals 2. Let's just check it real quick. I'm going to check with 5. So let's go back to my original problem. Let me erase my onion out of here so we can actually see this better. And get rid of my onion. Okay, so let's plug in 5. 2 times 5 is 10. 10 minus 7 is 3. So I have 3 in absolute values. The absolute value of 3 is 3. 3 times 3 is 9, and 9 minus 5 works out to 4. That checks out. So that's how you can check your answer. Okay? Let's quickly try a couple of our own. Okay, so for number 2, is the absolute value by itself? And I hope you're looking at that and saying, well, yeah, it is. Okay, good. So that's easy then. Just write two equations, one with the positive 9 and the other with the negative. So r minus 7 has to equal 9. R minus 7 has to equal negative 9. And solve each one. So add 7. R equals 16. There's one answer. If I add 7 on this one, R would equal negative 2. There's my other answer. Okay? Let's try this one. Is the absolute value by itself? No, it's not. And let me take my highlighter and show why. I don't want the 2 here, and I do not want the plus 4.1. I don't have the absolute value by itself. So let me onion the absolute value. The absolute value is the center of the onion. I don't want the 2 out here, and I certainly don't want the 4.1. So I got to peel away one layer at a time. Let's get rid of that 4.1 first. It's the outside layer. So I'm going to subtract 4.1 from each side. So 2 absolute value S equals, if I'm doing this in my head right, that'd be 14.8. And then I can divide by 2, and that would give me absolute value S equals, if I'm doing this in my head right, 7.4. Now, there's my equation. I get 2 answers to this. One would be positive, one would be negative. So one answer would be S equals positive 7.4. The other answer would be S equals negative 7.4. Okay? Let's do one more. Let's do number 4. I'll write it down here. So you can see I wrote the problem out. Let me take my highlighter out. Is the absolute value isolated before? I got to do that first. And, well, no, it's not. I got the 4 here, and I got the minus 5 here. I want the absolute value all alone. Okay, so let me draw my onion up. The absolute value is the center of the onion. The times 4 is the next closest thing. That's the next layer. The minus 5 is the outside layer. So let's start peeling away. I don't want minus 5 out here. I'll add 5 first, and that gives me 4 absolute value T plus 9 equals 24. I got to get rid of the times 4 yet, so let's divide by 4, and that gives me absolute value T plus 9 equals 6. Okay, now that I have the absolute value by myself, I can write 2 equations, one with the positive and one with the negative. So T plus 9 would equal 6. T plus 9 would also equal negative 6. These are easy to solve. We'll take away 9. T would equal negative 3. There's one solution. If I take away 9 here, T would equal negative 15. There's the other solution. So there would be my solutions to that. Now, it's important, and this is why at the beginning of the video I tried to make it clear. Absolute value means distance, and distance is always positive. Absolute values have to equal positive amounts. So the absolute value of a number can never be negative. So when an absolute value expression equals a negative, that means there is no solution. So look at this example here. This would be an example of a problem that's going to work out to no solution. Here's why. Do you notice the absolute value is not by itself? There's a plus 6 outside of it. I got to get the absolute value by itself first. So I'm going to take away the 6 from each side. When I do that, plus 6 minus 6 cancel, but now over here I get negative 2 minus 6 is negative 8. Now look at this statement. Do you see absolute value equaling a negative? We have an issue here. Absolute values can't equal negatives. So for this problem, there would be no solution to this problem. You would just write on your, once you get to this step, you would just write underneath it, no solutions. Absolute values cannot work out to negative amounts. One more vocabulary word we have to finish up before we finish the video. Absolute deviation of a number, x, from a given value is the absolute value of the difference of x and the given value. So you might be like, wow, that sounds really complicated, okay? Absolute deviation is a simple equation. It equals x minus the given value. Now, absolute deviation is sometimes called the margin of error. So when you think margin of error, the technical term for margin of error is absolute deviation. Now, how do we use that? Look at this example. Before the start of a basketball game, a basketball must be inflated to an air pressure of 8 pounds per square inch. So that's what I want. I want the basketball to have that much air pressure. But it has an absolute error of a ½ pound per square inch. So that would be my margin of error. So 8 is my given value. The half is my absolute deviation. That's my margin of error. And they want me to find the minimum and maximum acceptable air pressures. That would be my x. So let's look at what they write. They put 0.5 in for the absolute deviation, The measured air pressure, we don't know. We're trying to figure out what those are. And the accepted air pressure, the given value, is 8. Well, there's their equation. It's 0.5 equals absolute value P minus 8. Now the absolute value is all by itself, so I can write two equations. One has the positive answer, 0.5. The other has the negative answer. And then all I got to do is add 8 to each side, and this would show me what the maximum and minimum pressures for the ball could be. So if I overinflate the ball by a half square inch, the top air pressure I could have and still have the basketball legal would be 8.5 psi. And the minimum would be over here, it'd be 7.5 psi. That would be the maximum minimum value. I'm going to stop the video here. If you have any questions, make sure you ask in class.